Good morning, everyone. Welcome to the Numberland, where physics meets imagination. Today, we will explore how things move, how forces act, and how energy works, from speed and acceleration to work, power, and momentum. So, grab your notebook. It's time to make physics simple, smart, and fun. By the end of this session, students can number 1 distinguish speed versus velocity and compute acceleration. Number 2 apply SUVAT equations for uniform acceleration and free fall. Number 3 use Newton's law to find resultant force and acceleration. Number 4 compute work, energy, power and efficiency. Number 5 apply momentum, conservation and impulse. Number 6 use momentums for balance. Number 7 calculate density, pressure and upthrust. So let's start. We are starting a 7-day complete plan with all topics covered, numericals, including each and everything MCQs. Now let's start today's day 1, that is kinematics. Motion describes how position changes with time. Speed is distance per time, scalar quantity. Vector is displacement per time, vector has direction. Acceleration is rate of change of velocity. I am showing on screen the formulas and now it's time to graph skills. Dun, dun. Now come to the graphs. We have type 1 distance time graph where gradient is equal to the speed. Look at on the screen. Here I am showing all 4 types of type 1 graphs. In first, object is at rest. Next is when speed is uniform, graph is straight line. Next, when speed is not uniform and increasing, graph is curved. And now speed is not uniform and decreasing. Graph is like this. Got it? In velocity time graphs, we have 5 cases. Case 1 with a constant velocity. Look at on the screen, a horizontal line parallel to the time axis, no change in velocity, so acceleration is equal to 0. For example, a car moving steadily at 10 meter per second, key gradient is equal to 0, acceleration is also equal to 0. Area under line is equal to the velocity into time, that is equal to displacement. Case 2, uniform acceleration, a straight slanted line rising upward. Velocity increases at a constant rate. For example, showing here a ball rolling down a slope, key gradient, it's equal to a constant, it's equal to a acceleration. Area under the line, it's equal to the displacement. For example, if velocity increases from 0 to 20 meter per second in 5 seconds, then I am showing the mathematical terms here on the screen. Look at there. Case 3 is uniform deceleration. Now a straight line sloping downward, velocity decreases evenly. Constant negative acceleration, slowing down. For example, braking a car. If velocity decreases from 20 meter per second to 0 meter per second in 4 seconds, mathematical terms are showing on the screen. Area under line, it's equal to half multiplied by 20 plus 0 into 4, that is equal to 40 meter displacement before stopping. Case 4, non-uniform acceleration, curved line not straight. Acceleration changes continuously. For example, rocket Launching speed increases rapidly. Here acceleration is equal to the changing slope of curve. You can find instantaneous acceleration by drawing a tangent. Look at on the screen. Okay, now case 5, when motion in opposite direction. Look at on the screen. When the line goes below the time axis, velocity is negative. That means the object moves in the opposite direction. For example, downward or backward. Area below the axis represents displacement in the opposite direction. Now, how to find displacement from the graph? Look at on the screen. Displacement is equal to the area under the velocity time graph. For straight lines, use area of triangle plus rectangle. For curves, estimate area by counting squares or dividing into small trapeziums. For example, if an object accelerates from 0 to 10 meter in 4 seconds, triangle shape. I am showing mathematical calculation on the screen. That displacement is 20 meter. That's it. If you learned something new today, don't forget to like, share and subscribe to Numberland, where every concept becomes crystal clear. See you in the next lecture. Goodbye.